So, good morning everyone. So, today I will explain what the meaning of TCP. So, what is TCP or IP model? TCP is a significant part of the process of creating something is the ability to imagine things that do not yet exist. This skill was instrumental to the creation of the internet. So, if no one had imagined that underlying technology that most now take the granted every day, so, there would be no cat memes. So, ang TCP is, wala na din siya cat memes. So, to make the internet possible, two things that needed imagine were layers and protocols. So, layers are conceptual divides that group similar functions together. The word protocol, it means that the way we've agreed to do things around here, or more or less. In short, both layers and protocol can be explained to a 5-year-old as ideas that people agreed sounded good. And then they wrote them down so that other people could do things with the same ideas. The Internet Protocol Suite is described in terms of layers and protocols. Collectively, the suite refers to the communication protocols that enable our endless tooling. So, it's often called by its foundational protocols. The TCP or Transmission Control Protocol in the Internet and the IP, the Internet Protocol, and lumped together as TCP or IP. These protocols describes how data on the internet is packaged, addressed, sent, and received. So, TCP or Transmission Control Protocol and the IP Internet Protocol, these protocols describes how the internet is packaged. So, layers are imaginary. So, what is layer? So, if you consider the general nature of a rainbow, layer is a sponge cake. So, kung atong i-consider sa pagkaon or nature ang layers, ang atong example is sponge cake. Sponge cake is smoothly made of soft, melt in your mouth, vanilla goodness. So this goodness is in itself compressed of something along the line of eggs, butter, flour, and sweetener. So, marag ang ingredients ang sponge cake, so nago na siya egg, butter, flour, and sweetness. So, mamaora na siya sa pasabot sa layers. There is not much to distinguish one layer of rainbow sponge cake from another. Often, the only difference between layer is the food coloring. So, ang difference between sa layers, ang kanarang food coloring and a bite of frosting. When you think about it, it is all cake from top to bottom. The rainbow layers are only there because the baker threw the oat to be. So, similar to cake ingredients, layers in the context of computer networking are mostly composed of protocols, algorithms, and configuration with some data sprinkled in. So, ang layers, mamora po na siya sa cake nga na siya ingredients. So, ang ingredients sa layers, na siya, nag-compose na siya of protocols, algorithms, and configuration. Then, with some data sprinkled. It can be easier to talk about the computer networking if its main functions are split up into groups. So, certain people came up with description of layers, which we call network models. TCP or IP is just one network model among others. In this sense, layers are concepts, not things. Some of the people in questions are part of Internet Engineering Task Force or IETF. IETF, Internet Engineering Task Force. So, the IETF, they created the RFC 1122 publication. They are discussing the internet communication layers, half of a whole the standard. Covers the communication protocol layers, link layers, IP layer, and transport layers. Its companion RFC 1123 covers the application and support protocols. So the layers describe RFC 1122 and RFC 1123. Each encapsule protocols that satisfies the layer's functionality. Let's look at reach of these communication layers and see how TCP and IP stack up in this model of the internet layer cake. So link layer protocol. What is link layer protocols? The link layer is the most basic or lowest level classification of communication protocol. So, ang pinaka masayon o pinakaubos na layer is link. It deals with sending information between hosts on the same local network and translating data from the higher layers to the physical layer. So, ang link layers, usapon siya nag-send sa mga information and translating data from higher layers to physical layers. So, protocols in the link layer describe how data interacts with the transmission medium, such as electronic signal sent over specific hardware. Unlike other layers, link layer protocols are dependent on the hardware being used. So, ang link layers, nagdepende na po siya if unsang hardware ang gigamit sa iya. Then, protocols in the internet layers describe how data is sent and received over the internet. The process involves packaging data into packets, addressing and transmitting packets, and receiving incoming packets of data. So, the protocols describe siya o data to send and receive sa internet. And also, ang iyang proseso nag-involve po siya o packaging data into packets and nag-transmit siya o and also transmitting packets. So, the most widely known protocol in this layer give TCP or IP is the last two letters. IP is a connectionless protocol, meaning that it provides no guarantee that packets are sent or received in the right order, along the same path, or even in their entirely. Reliability is handled by other protocols in the suite, such as in the transport layer. There are currently two versions of IP in use. So, naay duha ka version ng IP, IPv4 and IPv6. So, both IPv4 and IPv6 describes how devices or internet are assigned in IP addresses, which are used when navigating to cat memes. So, IPv4 is more widely used but has only 32 bytes for addressing. So, ang IPv4 na siya 32 bytes, allowing for about 4.3 billion possible addresses. These are running out, and IPv4 will eventually suffer from address exhaustions as more and more people use more devices on the internet. The successor version, IPv6, aimed to solve addresses exhaustion instructions by using 128 bytes for addresses. So, ang IPv6 is ang iyang purpose is mag-solve siya og mga address. Then, ang na siya ay 128 bytes. So, this provides a lot more addresses possibilities. So, the next is transport layer protocols. So, transport layer protocols in May 1974, Van Cerf and Bubkan collectively often called the fathers of the internet. So, si Bob Kahn in 1974 iyang gitawag og the fathers of the internet. Published a paper entitled A Protocol for Packet Network Intercommunication. This paper contained the first description transmission control program, a concept encompassing what would eventually be known as the Transmission Control Protocol or TCP, and UDP is User Datagram Protocol. So, the transport layer presently encapsulates TCP and UDP. Like IP, UDP is connectionless and can be used to prioritize time over reliability. TCP, on the other hand, is a connection-oriented transport layer protocols that prioritize reliability over latency or time. So, TCP nag-describe siya transferring data in the same order as it was sent, transferring lost packets and control affecting the rate of data transmission. So, the next is application layer protocols. The application layers describes the protocols that software application interact with most often. The specification includes description of the remote login protocol telnet, the FTP or file transfer protocol, and SMTP, the simple mail transfer protocol, also included in the application layer, are the hypertext. The HTTP is Hypertext Transfer Protocol. It is successor or HTTPS, Hypertext Transfer Protocol Secure. So, ang Hypertext Transfer Protocol Secure or HTTPS is secured by Transport Layer Security or TLS, which can be used to be the topmost layer on the networking model described by the Internet Protocol suite. So, ang link layer man siya basic ra siya niya gamay lowest level classification of communication protocol, while transport layer while application layer protocols describe siya sa mga protocol that software application interact with most often. So the next is how to determine the number of subnets and the number of hosts of subnets. Two formulas can provide these basic informations. So, number of subnets, man siya second subnet formula, or number of subnets 2 minus 2, number of hosts per subnet equals 2 minus 2. So, i-determine natin how to determine the subnet. So, both formulas calculate the number of hosts or subnet based on the number of binary bytes used. For example, so if you borrow the 3 bytes from the host portion of the address, use the number of subnets formula to determine the total number of subnets gained by borrowing the 3 bytes. This would be so. Yung answer is 8 subnets. So, ang formula kay ana siya 2 times 2 4. So 4 times 2 is 8. So na siya 8. So ihang answer is 8 subnets. So to determine the number of hosts per subnet, you would take the number of binary bytes used in the host portion and apply this to the number of hosts per subnet. Formula: if 5 bytes are in the host portion of the address, this would be so 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2 so 32 hosts. When dealing with the number of hosts per subnet, you have to subtract 2 addresses from the range. So the first addresses in every range is the subnet number. So the first address in every range is the subnet number. So range is the broadcast addresses. So these 2 addresses cannot be assigned to any device in the network, which is why you have to subtract 2 addresses to find the number of usable addresses in each range. For example, if 2 bytes are borrowed for the network portion of the address, you can easily determine the number of subnets and hosts per subnets using the 2 formulas. So, for example, if 2 bytes are borrowed for network portion of the address, you can easily determine the number of subnets and hosts per subnet using 2 formulas. So, there are 2 formulas numbers. Ang formula is number of subnets equals 2 minus 2. The number of hosts per subnet equals 2 minus 2. So, muna siya yung formulas. So, as you can see, na siya 0 diri. So, ang meaning ana is the number of subnets created by borrowing 2 bytes is 2 or 2 times 2 equals 4. Subnets 2. Then, ang 0 diri is the number of hosts created by leaving 6 byte is 2 minus 2 or 2 times 2 times 2 4 4 times 2 8 8 times 2 16 16 times 2 32 32 times 2 64. So in formula is 2 minus 2 so 64. The number of hosts created by leaving 6 byte is 2 minus 2. So 64 minus 2 equals 62. Usable hosts per subnet. So the next is binary to discipline conversation. So asa gikuha ning 146 nga answer. So ang nasa scratch example asya 128 16 2. So imo na siyang i-add. So ang answer is 146. So 128 dapat imong bulungon ang naay 1 kanang 1 asa na siya natunong. Muna siya imong i-add. For example, ang 128 natunong siya sa 1. So, 128. Ang 64 natunong, ang 64 wala man siya natunong. Wala man siya 1 diri, 0 man niya. So, wala siya apel. Ang 32 po wala siya apil. So i-add na naman ang 16 kay na siya 1, so tanta direct 16. Ang 8 kay wala, ang 4 then wala. So ang 2 kay naman siya 1, so 2. Ang 1 is wala. So imo siya i-add ang upat ka item ay ang tulo ka numbers nga na ay 1, so which is 128, 16 o 2. So 128 plus 16 pila man ron? 128 bugo kay ko nga 128 29 3 4 5 6 7 8 128 29 3 4 5 6 7 8 9 10 3 4 so 144 plus 2, so 144, 45, 46. So ang yung answer is 146. So napay another example. Si 128 wala siya apil kay 0 man ang nakabutang. Si 64 apil siya kay naman siya 1. Na may 1 nga natungod. And then si 32 na siya 1, so ako siyang gibutang diri na 32. Si 16 na siya 1, so 16. So si 8 0 man siya wala siya apil. So si 4 na siya 1, so apil siya. Si 2 na siya 1. Natungod ang 1 sa 2, so na siya diri. Then ang 1 natungod siya sa 1, so 1. So ayang answer is 119. So ang 119 iko ang naka-i-add ang 64, 32, 16, 4, 2 ug 1. So 64 plus 32, so 64 plus 32, 60, 72, 90, 94, 95, 96. So 96. 96 plus 16. 96, 70, 900. Ay, 96 times 96 plus 16. So 112 plus 4. 116 plus 2, 116, 118 plus 1, 119. So sayon ra siya, sayon ra nga kuan, sayon ra jud ning binary to decimal conversation. Kay bulungon ra man nimo nga ang kaning given nga 128, 64, 32, 16, 4, 2 ug 1. Basta kung na sila natungod nga 1 diri, apil imo siyang i-add kung asa ang naapil nga 1. Asa siya na apil. Kung na siya 1, so apil siya. If 0, wala siya apil. So other example is 128 na siya 1. So 128. Ang 64 na siya 1. So 128 plus 64. Then 32 na siya 1. So plus 32. Then 16 plus 1. Ay 32, then apil naman siya 1 ang 16. So i-add nimo 32 plus 16. Then plus 8 kaya naman siya 1 plus 4 plus 2 plus 1. So 128 plus 64, 160, 160. So ano na siya? Ito edit. Ito. 128 plus 64, 160, 160 plus 160. So 160 plus 64, 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 160 plus 160 Hindi man siya ma-edit. Hindi siya ma-edit. Ako ta siya i-edit para makita na itong answer. So, may pag-edit na.
Kana kontra de.
Oh, ba naman?
Basta ano na siya. So, 128 plus 64. So, 128 plus 64, 128, 160, 70, 80, 158. So, 192. 192 plus 32. 124. 124 plus 16. 124, 25, 16. 224 plus 16. 124, 25, 16. Ang dili din sa ako i-calculate. Basta sayon na siya i-determine ang sayon ra i-kuan ang silan ang binary to decimal conversion. Kaya mo ra yung bulungon kung asa na ay given nga number, then asa natunog ang 1, asa na rin 1 niya, ya siya natunog, mo na imo ipang-add. So, yeah. 128 plus 64. So, 192 plus 32, 224 plus 16, 240 plus 8. Plus 8. 248 plus 4, 252 plus 2, 254 plus 1, 255 ang answer ani. Kaning 128, 64, 32, 16, 8, 4, 2, 1. Ang iyang answer is 254. So, last example is last example. Ito i-zoom. Ang 128 na siya 1. Ang 64 na siya 1. Ang 32, so wala siya appeal kay 0 man siya. Ang 16, wala po siya appeal. Ang 8, wala po siya appeal. Ang 4, na siya 1. So, appeal siya. Ito siya i-add. Ang 2, dili siya kay 0. So, ang 1 is na siya. So, 128 natin yan. So, ang appeal ani is 128 plus 64 plus 4 plus 1. Ano siya? So, ito yan. 128 plus 64. So, 128 plus 64 is 192 plus 4. Simsa. 128 plus 64. 192. 192 plus 4. 196. 196 plus 1. So, 197. So, ang iyang answer ini is 197. So, inana na siya guys. Sayon na siya to kuan to answer the binary to decimal conversation. Basta kung na given nga number, mani ang given nato 128, 64, 32, 16, 8, 4, 2, 1. Then if asa na to nung mga 1 ani nila nga gipang given na numbers, di mora pa nato ipang add. Kani 128, gi-add na to ang 16, gi-add pud ang 2. Nana lang kasi yun. So, mo to siya guys. Mora ang ako ang explanation about what's the meaning of TCP and brief explanation about subnet and the binary to decimal conversation. Thank you guys. Bye.